Standard deviation for grouped data. If you're given a frequency distribution, okay, we're going to need to estimate the standard deviation for a frequency distribution. That formula is the square root of, just like it is for the straight standard deviation, the sum of, and look at what we have, x minus, this is a sample mean, x bar is the sample mean, quantity squared, that's essentially the same thing as we did before, but this time I'm going to be multiplying that value times the frequency of that x. To do a straight standard deviation or variance when you have all the data values given, you might have 3 occur a few times, but you would count them all separately. In a frequency distribution, all of your numbers are grouped together. And so that's where the frequency comes in. We're going to divide that by the difference squared for each term. And then we divide by n minus 1 again, the same as we did for the straight sample standard deviation. Now, when a frequency distribution has classes, we're going to estimate the sample mean and standard deviation by using the midpoint of each class. Now, hopefully, you've gotten pretty far through week 2 material in ALEKS, and you've gotten to practice doing the frequency distributions, drawing them, drawing frequency polygons, and basically counting up how many times these items occur. And so you'll understand about the midpoint of each class. But here's an example. This is from ALEKS. Students at a major university in Southern California are complaining about a serious housing crunch. Many of the university students, they complain, have to commute too far to school because there is not enough housing near campus. The university officials' response is to perform a study. Isn't that just like them? What does class mean? Sandra, hang on just a second. I'll get to it. It's right here. The study reported in the school newspaper contains the following histogram summarizing the commute distances for a sample of 36 students at the university. A class is a subdivision. So our different distances will get grouped into everybody that travels between 0 and 4 miles will be one group or class. Everyone goes between 4 and 8 miles will be the second group or class. And you can see we have 15 of those. So 6 people travel between 8 and 12 miles. 3 people travel between 12 and 16 miles. So now the question is, estimate the standard deviation of the sample of 36 distances. So, excuse me. So, first I want to note that the first class runs from 0 to 4, and then 4 to 8, 8 to 12, 12 to 16. Our first frequency is 12, second frequency is 15, 6, and then 3. You'll see how that comes into play on the next screen. So 12 people drive between 0 and 4 miles, 15 between 4 and 8, 6 between 8 and 12, 3 between 12 and 16. So we're going to find the midpoint of each class. So the class 1, this first one, the class 1 midpoint, you simply add the first and second part of it, the beginning and ending endpoints. So 0 plus 4 over 2. 0 plus 4 is 4, divided by 2 is 2. Second class, 4 plus 8 is 12, divided by 2 is 6. Class 3, 8 plus 12 is 20, divided by 2 is 10. In class 4, 12 plus 16 is 28, divided by 2 is 14. So our midpoints are 2, 6, 10, and 14. So to find the mean of the 36 estimated values, first off, the formula for a weighted mean, a mean of a frequency distribution, is the sum of x times the weight divided by the sum of all the weights. So this first part, this top part, the sum of x times the weight, x was the x is the midpoint, which the first one is 2, times the weight, which is the frequency, which is 12. Hang on a second. I'm going to change how this looks a little bit. I'm going to do, first off, instead of W, I'm going to do F, because I think that that is hang on a second, you'll understand in just a second. I'm switching these around so they match the formula. There we go. So, the weighted mean is the sum of each individual x, which is the midpoint, times the frequency from that class, divided by the sum of all the frequencies, which is also n. So the sum of x times the frequency. The first midpoint was 2. There were 12 of them. The second midpoint is 6. There were 15 of those. The third midpoint was 10. There were 6 of those. And the fourth midpoint was 14. There were 3 of those. Okay? So then just 12 times 2 times 12 is 24, 6 times 15 is 90, 10 times 6 is 60, 14 times 3 is 42. Add them all up and divide by the sum of the weights, which is it comes out to the total number of items, which is n, which is 36 in this case. So 216 divided by 36 is 6. So the mean of this frequency distribution, here's our frequency distribution. We had 12 items with a midpoint of 2, 15 items with a midpoint of 6, 6 items with a midpoint of 10, 3 items with a midpoint of 14. And when we multiply and add, we get an average of 6 from this frequency distribution. Okay, so that's our mean. Now, continuing, the estimate of standard deviation for grouped data is this formula. The standard deviation is the square root of the sum of x minus the mean squared times the frequency over the total sample size minus 1. Here's the formula. So then we're going to take the frequency times x minus the mean, square that, frequency, x minus the mean, square that, frequency, x minus the mean, square that. So I did not work it out one step at a time, but that all adds up to 13.7143. Take a square root, and we get an estimate for sample standard deviation of 3.7. And indeed, this explanation is straight out of ALEKS.